Let's look at the first question. So here we have two equations, a minus 6b plus 6c. Let me write it down. We have a minus 6b plus 6c equals to 4, and we have 6a plus 3b minus 3c equals to 50, where a, b and c are real numbers. Okay, and we have to find the value of 2a plus 3b. So I'll write f. This is what we have to find: 2a plus 3b minus 3c. You have to find this value. Now, normally we know that if we have three variables, we need three equations to solve it. That is how you solve. That's the process. But in this case, we only have two equations, but we have three variables. So how do we go about this? So the strategy here is that we have to turn the three variables into two variables somehow. And if you look at this, it's actually quite simple. So if you look at 6b plus 6c here and 3b minus 3c, so in some ways you can take, okay, let's look at the first equation. So the first equation you can write, you can take the 6 out and you can write the rest as b minus c equals to 4. So let's mark it as equation 3, and equation 2 we can write it as 6a plus 3 b minus c equals to 50. See, now you can see that we can take the b minus c as common. That is, we can assume b minus c to be another variable k. So now we have an equation of two variables, and then we have two equations. In fact, if you look at this equation 2, this can also be written in the same format: 2a plus 3 b minus c. So if you replace it with k, this becomes 2a plus 3k. So now what we have equations. So we can write the equation 3 as a minus 6k equals to 4, and we can write equation 4 as 6a plus 3k equals to 50. Now it's very simple. We just have to solve these two equations. So equation 5 can be written as a equal to 4 plus 6k. It's equation 7, and then we can replace this a here. So this becomes 4 plus 6k plus 3k equals to 50, which becomes 24 plus 36k plus 3k equals to 50. Yes, so 39k equals to 50 minus 24. This implies 39k equals to 26, which can be written as k equals 26 by 39. Now both of these are multiples of 13, so 13 times 2 equals to 26, 13 times 3 equals to 39. So k equals to 2 by 3. So we got the value of k. Now if we plug this value of k back in this equation, we'll get the value of a. So equation 7 implies a equals to 4 plus 6 times 2 by 3. So cancel this, we get a equals to 4 times 4 plus 2 times 2, which is 4 plus 4 equals to 8. So So as you can see, we got the value of both a and k. Now we have to plug the values of k, a and k here. This is what we are trying to find out. So we found a to be 8 and k to be 2 by 3. So 2 times 8 plus 3 times 2 by 3. So this implies 16 plus 2 equals to 80. So this is our answer. So the answer should be A, 18. So if you look at this, it's 18. Now let's look at question 2. So here this is a permutation and combination question. So what we have is that we have a cafeteria that offers 5 types of sandwiches. For each type of sandwich, a customer can choose 4 types of breads, and they can opt for either a large or a small sized sandwich. So up till here it's very simple. So what you get, it is just the combination. So five types of sandwiches we have, and for each of the 5 there could be 4 types of breads, and for each of the 4 types of breads, the customer can choose whether they want the large one or they want this small one. So 4 times 5 times 4 times 2. Now the next sentence. Optionally, the customer may also add up to 2 out of 6 available sauces. So now here it's tricky, because on the first read you might think it's saying that the customer can choose 2 out of 6. So the next thing we could, so you might write it as, okay, it's just a combination. So 62. So how many times you can choose 2 out of 6? And then you calculate and you will get an answer. But that's actually the wrong one. Why? Because you have to pay attention to the word that they are using here. It says the customer may also add up to 2 out of 6. That means 2 is the upper limit. So the customer may also opt 0 sauces out of 6, or it may opt 1 sauce out of 6, or 6 sauces out of sorry, let me just say that again. The customer may opt 0 sauces out of 6, 1 sauces out of 6, or 2 sauces out of 6. So it's not saying that the customer has to choose exactly 2. It may choose 0, 1 or 2, but it cannot choose more than 2. So 2 is the upper limit, it's not the exact number. So there are multiple possibilities. So we have to take into account all of those possibilities. So this approach is not going to work. Instead, what you have to do is that you have to take 5 into 4 into 2, up till here it's common. Now we have to take into account all of the scenarios. In how many ways can the customer choose 0 sauces? Plus, in how many ways can the customer choose 1 sauce? And in how many ways the customer can choose 2 sauces? So this is our equation. This is our term, which is what we have to solve for. 5 into 4 is 20, 20 into 2, 40. Then 60 is 1, because there is only one way you can select, no sauces. And how many ways can you select 1? 61 is 6. Now 62, the formula is 6 factorial by 2 factorial by 6 minus 2 factorial. So let me solve this separately. 6 factorial times 2 factorial times 4 factorial, which is equals to 6 into 5 into 4 factorial, 2 into 4 factorial, 2 into 1 into 4 factorial, to be technically correct. So 4 times 3, okay, so this turns out to be 3 into 5, 50. So now coming back to this, 40 into 1 plus 6 plus 50. This is equals to 15 plus 6, 21 plus 1, 22. So 22 into 4 is 880. So the number of ways is actually 880. So the answer is A. So let's check it. Yes, that's A.